Good morning, everyone. Thanks a lot for joining us in today's webinar, Fast Concept Generation for Early Feedback when Designing Battery Cold Plates. My name is Tasneem Ahmed Anwar, and I am a sales engineer here at Diabatix, and I'll also be your tour guide for today's discussion. To place in the agenda, the idea of today's discussion is to dive deeper into our generative design and thermal simulation tool, ColdStream. We'll also have a look at the fast concept generation aspect of thermal design and how ColdStream is able to generate some great feasible designs within a few hours. I'll also give you a hands-on overview so you have an idea of how a typical ColdStream user will set up a case but also get some results in our tool. Having said that, let's already begin. To give you an insight of where we come from, the name of our company is Diabatix. We are a Belgian-based company with our product ColdStream in the market for over 3 years now. Through our technology, the vision of our business revolves around enabling engineers with smart algorithms so they can design limitlessly. This is what we do with our product ColdStream, which has helped us affiliate ourselves with experts in their field, ANSYS and Hexagon, which have actively become our technology partners as well. Having said that, we can already start talking about ColdStream, or of course, how ColdStream's generative design process challenges the status quo with the conventional design process that is mostly in use as of now. When we talk about a conventional design process, as you can see over here on the left, they often involve trial and error, lengthy iterations, and limited explorations to design alternatives. This can be challenging, especially when you're dealing with complex thermal management scenarios or, of course, complex objectives to achieve. Unlike the conventional design process, which relies heavily on manual iterations and predefined parameters, ColdStream harnesses the power of algorithms and generative design. It explores countless design alternatives, iterates rapidly, and unveils solutions that might not be immediately apparent through traditional, or of course, manual engineering processes. To give you a better insight of how ColdStream really plugs in at any point of your design cycle, whether it be the early conceptualization phase where you have an initial design domain and you want some great concepts to start off with, ColdStream is able to generate some good feasible designs within a few minutes to maximum a few hours. And then of course you have the full-fledged design optimization capability of ColdStream, which helps you leverage on generative design or thermal topology optimization, as we call it, till we get to final optimized design. In today's discussion, I wanted to dive deeper into the fast concept generation capability of ColdStream, which basically leverages on correlation-based estimations to help you generate some great first few concepts by conducting hundreds of iterations in the backend and giving you a better first few starting points and amplifying your conceptualization phase till, of course, you get to the full-fledged optimization and help you with your final most desired solution. ColdStream amplifies your conceptualization phase by not only helping you get to these concepts at a much faster rate, but also helping you get to a better starting point before you actually start optimizing for the full-fledged thermal topology optimization. But before we actually get into the technicalities of things, let's first ask ourselves, why do we really need these early concepts? And you really talk about the concept generation capability of ColdStream, and you talk about significantly accelerating your iteration cycles, this not only enables you to get to a better starting point, but also helps you have a crystal clear view into the early design stages of your design process. With ColdStream, you bring in unparalleled transparency with these initial phases, but at the same time gets you to much more informed decisions at a much more swifter rate before, of course, you leverage on the full-fledged optimization for your designs. Traditionally, we've been confined to exploring maybe a limited number of design alternatives. Coldstreams opens doors to much more alternatives, initial designs, but also gives you a comparative study on which concepts are performing better than the other. Of course, I love to dive deeper into this, but before I really get on at a much more hands-on level, I'd love to address how a typical workflow for an engineer at Coldstream looks like. So in Coldstream, we focus on simplicity. So the learning curve of this tool as a whole is also very short. So you really don't need a highly trained thermal or CFD engineer to start working on Coldstream, basically because of how simple the workflow really looks like. As you can see over here, it's a typical or a straightforward four-fold process, starting off from you uploading your CAD geometry, or in this case, your step file. Once you've uploaded your step file into the Coldstream environment, you basically set the solids and fluids you're working with. So Coldstream has a library of different materials that you can choose from for your solids or fluids. But then of course, if you're working on with your custom solids or fluids, you can easily add them into your Coldstream environment by their thermal properties as well. Once you've set the solids and fluids for your power and subcomponents and your coolants, then you can actually go for setting up the boundary conditions. So what are the boundary conditions your component is playing around? Whether it be the heat sources, whether it be the volumetric flow rate or the mass flow rate in your inlet, basically these boundary conditions need to be input in your Coldstream environment. Once you're done with this, that brings us to the final stage where you're setting up the target functions or the objectives you're looking to optimize for. These could easily range from algorithmic target functions like temperature minimization, temperature variance minimization for keeping the thermal uniformity, temperature spread minimization, pressure loss minimization, or numerical constraints like mean temperature within a particular range, pressure loss within a particular range, maximum temperature within a particular range. So you can easily choose between numeric and algorithmic target functions. And just another thing to emphasize on, you have no limits on the number of target functions you can look to optimize for. So you can easily add multi-objective cases. And of course, once you've set your target functions, just to recap on the four-fold process: uploading the CAD geometry, setting the solids and fluids, setting the boundary conditions, and the targets you're looking to optimize for. Once you're done with this, you can actually submit the case in your Coldstream environment and wait for the generative design magic to happen. Now, typically looking at some great concepts, as you can see over here, generated by Coldstream, you can easily generate some great first few concepts by Coldstream conducting hundreds of iterations in the backend within a few hours. To give you a better idea of course, how Coldstream really leverages on its manufacturability aspect, I think this slide really helps you understand that better. One of the core components or one of the core values that we bring with our designs on Coldstream is that we always leverage on manufacturability. As you can see over here, one of the more important target functions that we feed into Coldstream in our fourth stage or the target stage is what kind of manufacturing technique we are limited to. As you can see over here, whether it be traditional manufacturing techniques like CNC milling, die casting, or of course, when you open doors to additive manufacturing or 3D printing, or if you're going with much optimal manufacturing techniques like sheet metal forming, Coldstream can easily leverage for each and every manufacturing constraint that you are limited to. And will make sure that the final designs optimized by Coldstream are always manufacturable. Having said that, of course, I'd love to give you a better overview of Coldstream with a much more hands-on or pragmatic approach. I think this brings us towards the end of this presentation, so I won't bore you a lot with much more words and information, but also show you how Coldstream or how an engineer would start working on Coldstream and get some great first few results. I think the best way to really look at Coldstream is at a use case level, and for today's discussion, I'll be diving deeper into the Dimples battery cold plate design use case that we solved. And of course, there are two sides of looking at Coldstream. One, which is the engineer's perspective or the user's perspective on how a typical case is actually set up. And on the other hand, we have the results and how to really look and evaluate the results that we get from Coldstream. I'll quickly touch up upon each and every aspect, but then again, we'll keep some round of questions, or some time for good questions towards the end as well. Having said that, let me just quickly move into my Coldstream demo environment. As you can see right here, some typical cases that we've solved for today's discussion. As I said, it will be battery cold plate. This is where we are, and now we're actually going to look at, of course, firstly the typical case setup and how an engineer would really look to work in Coldstream. In this case, let me just start off by showing you the setup. Again, recapping on a few slides that we saw during our presentation on how a typical workflow really looks like. Starting off from uploading the CAD geometry, or in this case, the step file. Normally we allow for step filed formats for the CAD file that you'll be uploading in your Coldstream environment. Once you're done with this, you can actually go around for setting up the solids and fluids. In this case, of course, we have a cover which is made of aluminum alloy, a stamp plate again made of aluminum alloy, and a fluid of course, water in this case that was working as our coolant. As I said, you can easily choose from a library of materials that you get from Coldstream, or upload or add your own custom solids or fluids if you're working around with them, just by adding their thermal properties as well. So once you're done with this, in this case, of course, we're not going to add any custom solids or fluids, but just to give you an idea of how or what kind of options you really have. So once you're done with setting up these solids and fluids, you can actually go around for setting the boundary conditions that you're playing or your component is playing around with. In this case, we have a battery pack with 3920 watts as our heat source. We have an inlet boundary condition of the volumetric flow rate and the temperature. And then once you're actually done with setting up these boundary conditions, you can actually go for setting up the target functions that you're looking to optimize for. Normally in your Coldstream environment, you get these target emojis over here, or these target symbols, just to give you an idea on where you actually set your objective functions or your target functions. Again, giving you an idea of what targets we actually went with. Firstly, starting off with the temperature minimization. Of course, keeping the temperature minimum, and of course also adding a temperature variance minimization just to keep the thermal uniformity in place. You can easily add multiple more objectives, as you can see from over here, whether it be temperature spread minimization, or keeping numerical constraints like maximum temperature within a particular range, minimum temperature within a particular range, or mean temperature within a particular range. So once you're done with target functions over here, of course, we've also added another target function in our inlet, which is the pressure loss constraint, or a numerical constraint of a pressure loss by keeping a 6000 Pascal as our limit. So you can easily add from different pressure loss related targets as well. So once you've submitted the target functions as well that you're looking to optimize for, your Coldstream case setup finally looks complete. Let's recap on what the workflow really looked like. Starting off from uploading your CAD file into your Coldstream environment, setting up the solids and fluids, setting the boundary conditions you're working with in the inlet, and of course your design domains and your heat sources, and then you actually look at the target functions you're looking to optimize for. An important thing to keep in mind is, of course, the design domain, or where Coldstream will really be working on or optimizing for. In this case, that is something that you really do, a bit of your homework that you do in your CAD file. In this case, of course, this is where the design domain really is placed, and this is where Coldstream's optimization will start working. Another important thing that we really, that I forgot to emphasize on is the manufacturing constraint that you're limited to. In this case, we've gone with sheet metal forming. Just to give you an insight, In your design domain, you have complete flexibility to choose from the manufacturing technique, as in this case over here for sheet metal forming, we have quite some manufacturing parameters that you can choose from. But of course, if you're going with a whole different manufacturing technique as a whole, you can easily change that from here. In this case, it also gives you some first few concepts or shapes that it can use as a great or better starting point. As you can see over here, we've gone with the circle for our dimples battery cold plate. If you were going for a rectangle shaped battery cold plate, we can easily choose that as well. So this basically allows Coldstream to really evaluate which should be the design that it should go for in terms of the concepts that it generates for you. Alright, so that of course brings us towards the end of the actual case setup side of things. But once you've set this case up, once you've let Coldstream know what your boundary conditions are, what target functions you're looking to optimize for, what the design domain looks like, and what manufacturing technique you're limited to, you can actually submit the case in your Coldstream environment. Now that we've seen how a typical case setup from an engineer's perspective looks like on Coldstream, let us have a look at some results as well, particularly the fast concept generator based results where Coldstream does a few iterations all in the backend within a few minutes to help you generate some good first few concepts as a best starting point for you to get the final design as well. As just going back to the case setup, in regards to what we did, we used a circular dimple based design as concepts that we wanted to generate, and let's look at how some results really look like on Coldstream. This of course is a typical result page with the case summary with some graphical overviews here, the thermal network diagram or the thermal network overview in regards to how the heat transfer is taking place, but at the same time the design evolution. The design evolution gives you an overview of all the iterations done by Coldstream in the backend and how these concepts look like for each and every iteration. As you can see right here, the x-axis is the iteration number and the y-axis is the performance value. It's a bit counterintuitive, but lower the performance value, the better the design is in terms of the thermal performance, and the most better it is in terms of feasibility in regards to the target functions we're looking to optimize for. Again, recapping on the target functions that we gave to Coldstream, basically temperature variance minimization, a pressure loss constraint, and a temperature minimization. And the best feasible concepts generated by Coldstream, as you can see over here, keeping in mind an overall design performance for all the target functions that we optimized for. The green ones that you see are the most feasible ones, and you can actually look or have a view of how the iteration evolved to each and every design. Just to give you a better insight, you also have a view of what the heatsink type is, what the manufacturing methodology is, and what the material for this heatsink or cold plate is. In this case, of course, we have a circular dimpled shaped battery plate, something that you can already let Coldstream know in the initial setup part that this is the shape we want to generate concepts for. But this was of course a typical result for the fast concept generator capability of Coldstream. Again, very much aligned to the case setup that we saw before this. Going back to the results, just an alternative or another way of looking at this case setup is by having multiple design domains. Let me just show that to you via the case setup side of things as well, so you have a better idea. When we actually go in the case setup and go through the design domain, in this case, in this peculiar setup, what we did was we divided the design domain in multiple regions through the inlet and outlet. As you can see over here, let me just show this to you. So this is the first design domain, the second, the third, the fourth, and the fifth. The reason we are doing this is basically because of how the inlet an outlet are placed and how the heat distribution will really vary. This, of course, is just another way of looking at the problem statement where you have not the most uniform heat distribution or heat source distribution, and you want to have a design domain separately and look at separate designs for each and every design domain. Let's have an idea of, or let's have a look at how the results would look like for such a case setup. Nothing is changing in this case setup apart from we just changing the design domains that we're looking to optimize for. So in this case, CoolStream should generate 5 different concepts for each and every design domain, basically allowing you to leverage on the full-fledged design optimization or concept generation capability of CoolStream. I'll quickly show you the results that were generated for the case setup that we just saw. The design evolution, where we had 5 different design domains, alternative to the first one where we had one whole design domain, you get 5 different designs, as you can see right here. Again, very similar result preview. Number of iterations, as you can see, close to 100-ish iterations, and as you can see, the performance value getting lower and the thermal performance getting better. So as you can see over here, starting off from the first iteration, where the designs for each domain looked like this, and as we go further and look at much more feasible designs, as they are linked as green as best feasible, you get to see some better concepts that are generated. Let's just go back and have a different view of this, like just to give you a better idea. You're not limited to just a particular set of shapes when you're generating some good concepts. In this case, of course, we went for the circular dimpled concepts. Let's look at how a rectangular dimpled concept would look like from CoolStream's results perspective. In this case, again, we've had 2 different case setups, one with 1 design domain and one with 5 different design domains. I'm not going to go into the specifics of showing you the case setup again. I'll just show you the result. Firstly, again, for the rectangular dimple concepts over here, similar results page, and then you go to the design evolution where you get to see almost 85 iterations done by CoolStream in the backend. These were all generated within a few minutes, and you get a good idea of what these most feasible concepts look like. As you can see right here, these are rectangular dimpled concepts. Again, similar case setup, just letting CoolStream know that the initial shape that we want is rectangular dimpled rather than circular dimpled. Now let's have a look at how a typical result would look like when you give CoolStream complete freedom to have, again, 5 different design domains, but allow it to use whatever concept or whatever shape that is best feasible for that design domain, keeping in mind the target functions and boundary conditions that we used in the case setup. As you can see right here, let me just quickly go back and show you another result page. In this case, first few concepts generated by CoolStream. Again, a similar case setup, 5 different design domains though, but allowing CoolStream to have complete flexibility in choosing whatever shape that suits best for that particular design domain. As you can see over here, this is what the design evolution looks like, with almost 100 iterations done by CoolStream within a few minutes, being able to generate some good first few concepts. As you can see over here, the first iteration has a rectangular dimpled for the 3rd design domain, a circular one over here, and then when it goes down, again a circular one, and then most of them being circular dimpled. Then when you actually go for the full-fledged or the final most feasible design, as you can see over here, you can actually see that again, as the iterations move on, the designs keep getting better, close to the most feasible designs that you're looking for as the first few concepts before you can actually go for the full-fledged optimization. And you can see that there's one rectangular dimpled while the others are all circular dimpled. So this basically is a better way of Coldstream allowing you to give full freedom to choose or select the right shapes for those design domains. But of course, if you want to go with a particular shaped concept that you want to generate, as we saw in our previous results, you can actually go for limiting Coldstream to those particular shapes as your concepts as well. So basically, Coldstream is intuitive enough to understand what would be the best case scenario for the case setup that you're going for, but it also gives you full control and autonomy to choose from, okay, I'm limited to these shapes, I'm limited to these manufacturing techniques, and I would want results focused on those aspects, and Coldstream leverages on those inputs to always generate results required for your needs. But yeah, this was in a nutshell Coldstream's capability to generate some first few good feasible concepts from the the inputs that you gave to Coldstream, starting off from uploading the CAD file, of course, or the step file, and then boundary conditions, the target functions you're looking to optimize for, and of course the shape that you want to generate in these concepts. So this, of course, was in a nutshell the fast concept generator capability of Coldstream. And having said this, I'd love to quickly go back to our slide deck and address any questions, technical or commercial, that you might have. Of course, please feel free to put them in the chat box so we can address them now that we have time. There's an interesting question asked about manufacturability and how we actually input the right shape that you want to opt for, or what kind of manufacturing setting that you're actually going for. Interesting question. Thank you so much for asking. I'll just quickly go back to show you how we actually go for normally submitting the manufacturing constraint that you're limited to in a typical case setup scenario. Again, this is back to my demo environment. I'll quickly go back to the case setup that we saw. Let me just quickly go to the design region again, the one that we had actually devised as the design domain for Coldstream to actually optimize for. And in this case, as you can see right here, we've gone for a circular dimpled manufacturing with sheet metal forming. Let me just quickly show you what a typical if when you want to change the manufacturing and shape, how it would look like. As you can see right here, you have all shapes, so you give Coldstream complete freedom to go for the most optimal shape that it would think would be the best, most feasible one for the boundary conditions and target functions that you fed for your case setup. Or of course, you can easily choose from these shapes, as you can see right here, pins, fins for CNC milling, 3D printing. You can easily go for gyroid based designs, diamonds, lidonoids, die casting, again, pin fin shapes. For sheet metal, again, you have circular or rectangular dimpled designs that you can actually choose from. This, of course, is for a much more conventional design optimization. When you go for the full-fledged design optimization of Coldstream, of a particular case setup, you can let Coldstream have complete freedom to go for a full-fledged thermal topology optimization for your case as well. But no, thanks for the question. And let me see if there is anything else coming our way. I see another interesting question in regards to having a demo for this tool. Apart from the demo that we had today, we also give our prospects a view for the typical case setup and the results that we saw with our Coldstream viewer access. Of course, I can reach out to you with some important credentials for you to have access to this account, where you basically are allowed to see some typical case setups, the results, and of course some demo use cases that we've completed. I think another alternate would be to have a personalized discussion with me, where we can actually dive deeper into a use case specific discussion, of course without getting into the technicalities of things, but help you understand how Coldstream could help better optimize your designs, or of course work as a strong thermal management or simulation tool for your use cases. Of course, if you're not able to reach us, you can always reach out to me personally via my email, as you can see right here. It's tasneem.anwar@diabatix.com. But yeah, I just wanted to thank you all for joining me in this discussion today. It was a pleasure to share some insights on how we are actually revolutionizing thermal topology optimization with our capabilities with Coldstream. I really look forward to having much more engagement with you guys so we can actually see how we can help you out. So feel free to reach out to me, and I hope to stay in touch. Thank you all.